Okay, so we are going to try to do section 7.5. We ended up leaving off on 7.4. And you're going to hear my kids talking a lot, even though I told them to be quiet, but they don't hear what I say. Okay, so we're going to do 7.5. This is properties of logarithms. I'm not 100% sure that you guys all did section. I'm doing great. Don's telling me that we're doing great. I'm doing great. I don't know if you guys all did section 7.4. I'm probably going to give some IXLs. I am talking to the computer. I know what I'm talking to. Okay, so we're going to do section 5, properties of logarithms. And I have like 5 IXLs already picked out too. But what I want you guys to kind of remember, there's a lot of different rules that we're going over, and I'm like weird in my house trying to get everything set up, and it's not how I want it. Nothing is how I want it right now. Okay, so some of the properties that you're going to use. I wish my Zoom control would come up and it doesn't stay up. All right, so our first thing that we're going to write out is that we're going to write, all my lights are shining in really weird directions. Okay, so we're going to have b to the power of x equals a. John, I need you to stop. Thank you. And then I have b to the power of y is equal to c. So we're using b to represent that something is a base, b for base. Okay, and then we also could have, just from these 2 points, we can have logarithmic properties. So if we took the log of both sides, or we rewrote these 2 exponential equations into logarithmic equations, what those would look like is that x is equal to log with a base of b, so that's that little guy, of a. Okay, so then this guy over here goes to y equals log base b of c. So we're going to play with these and kind of figure out some of the things that are going to happen here with these things. John, please be quiet, honey. Did this pause my recording? No, it didn't. All right, we had to take a break for me to smell John's breath because it smells like Cheez-Its, and he had to show that to me. Okay, so I want to rewrite this in a different form. I want to write that a times c. And I want to think about these 2 equations up here. What is a and what is c? So a is b to the x times c is b to the power of y. Okay, so as we're thinking about these properties, so these represent 2 of the same thing right now, okay? We just wrote on different sides of the equation, and we're going to write them in different ways. But over here on this side, what I want to remember is that b now has the power of what we think of as x plus y. Okay, so this is going to be really weird for a while, and then your equations and the stuff you'll actually be doing will be a whole lot easier. Okay, so then we're going to have a times c over here. And usually we really don't write dots for all our multiplications. We could just write ac, and that would still represent multiplication. Okay, so now if we were solving for x or y, we would have to take the log of both sides. Okay, so I'm going to write that. So I'd take the log of b of both of these sides, and then I would have log of b of this stuff over here. Okay, so what we're going to end up with is that, remember that this log b and this b, it basically just crossed off. So what I ended up with is x plus y equals log of b of ac. Okay, I can write a times c here. It doesn't matter if I write the multiplication or not. I don't have to write that dot for multiplication. I might try to zoom in later for you guys too, so you don't have to see this half of this stuff over here. Okay, but remember that we already wrote an equation for what x equals. Okay, so x, we're going to replace this x right here with a log base b of a. Plus, we're going to replace this y right here with this stuff. Log base b of c. Over here on this side, we're just going to rewrite this. Log base b and then parentheses. Sometimes you don't necessarily see those parentheses. Okay, so what this represents is this over here on this side. How many logs do I have on this side? I just have one single log over here. Logarithm. Okay, over here, I have what we call a sum of logarithms. So some of your things will be asking you to use the sum or difference of logarithms. Okay, this is a sum of logarithms. So some of your questions will ask you for that. So single logarithm over here has multiplication in it. We'll do some in a little bit with division. Usually we're not doing this much work, okay? So if I were to just give you something that said, what is the log base 8 of 4 times a, you would just, so this would be the single logarithm that they're giving you, and they're going to say write as a sum or a difference of logarithms. Or they might say like rewrite using logarithmic properties. So some of those words. Your next step, your final answer, the amount of work you have to show is that we write log base 8. So I made up 8. This is just a problem I made up, right? This is just an example. Okay, so with this example, I have log base 8 of 4 plus, because this had a plus over here, log, and do you see that I had both log base b's? I'm going to have both log base 8. Okay, so whatever base you have, you're going to keep those same bases. A. This is the single log. This is the sum of logarithms. This is it. You are done. This is the amount of work you have to do. We could go through this whole big work for difference of logs as well. So difference is just going to represent division. Okay, so this is the sum of logs. I'm probably just going to write logs more often now. Sum of logs. So addition is sum. So what you're going to have for the difference of logs, we're not going to go through all this, okay? This is just like a proof of how they ended up with this. The old dead guys that came up with this don't want to be doing this all the time. They just want different rules that we can use. Okay, so what we're going to do is we're going to have, if I had log base x, I can switch up my letters wherever they are, of a over b. Okay, so this is a single log over here on this side, and then I can switch it to my difference of logs. Whenever you see division, I'm going to use a difference of logs. Okay, so this is going to look like log base x of a. So whichever one is on top goes first. The division is going to represent a minus sign. Log base, same base x, and then the b was on bottom. Okay, so this is it. That's all you're doing. Just looked up at the screen and freaked out because I thought it wasn't recording. And so if I feel like I'm not recording something, let me know, because I would love to know if something's not working. An example of when we would use this, and we're just playing with these properties right now. We're not actually using them for anything, but we'll start using them in a little few days, week, I don't know that. Okay, so what that could look like is log base 2 of 5/6. So they're usually going to give you some directions that say write as a sum or difference of logs. Okay, so this is going to look like log base 2, and then we ask ourselves what was on top. 5 was on top. Minus, we need to write another log base 2 of 6, so whichever one was on bottom. Okay, remember this one got 2 different logs. They both had the same bases. Okay, the next property of logarithms that we have is the power property. Okay, this is all of logarithms. I'm not going to write of logarithms every time. But the power property of logarithms, what that is going to look like is log base b of m to the pth power. That is going, whatever we're going to do, we're going to take this power and we can move it out front. Okay, that's going to take a lot of work out of a lot of things that we have to do. Okay, so that'll be p times log base b of m. Okay, so an example of that in numbers, what that's going to look like is log, let me write example out, or just x. Okay, so if I have log base 2 of 6 to the 5th power, that is going to equal, so the 5 is the power, so the 5 comes out front, and then I have log base 2 of 6. Okay, that would be the only work I actually have to do for that one. So I've given you really simple ones right now. Let's combine all of these types of properties to do these. Let me yell at my kids a little. Okay, so I have some properties of logarithm types questions. So this one, how it says it is it doesn't say write as a sum or difference, which sometimes it does. It just says expand, and I know you guys can't see it, so I'm going to write each one out. It says expand each logarithm. I think I'm really just going to have you guys do some IXLs for this week, and then I will check them out. Let me know if you guys have problems with them. And I want you guys to just practice with all of these because that will make a lot of the stuff a little bit easier if you're good with these pieces. John, I need you to be quiet. Okay, so my first question is log of 2/3. Okay, so log of 2/3, if I ask you to expand that, what that is going to look like. So, John, please. Okay, that is just going to look like log 2, because there was a division, it's going to be minus log 3. And because I didn't have a base down here, we understand that base to be 10. Okay, so if we wanted to do one with multiplication, I would have log of 3 times 11. We don't want to change that out and write it as 33. We want to expand this. So in order to expand it, what it is going to look like is log base, or log of 3 times is going to become plus, and I write a separate log of 11. Okay, so they're kind of weird. Of course, everything needs unlocked. Okay, so let's do, I'm going to skip numbers eventually, so in case you wanted to find the same worksheet. But I'm not too worried about it. So I have log of 6 times 7, and then sometimes we're going to actually keep simplifying this. Okay, so these ones are pretty nice. So log of 6 plus log of 7. One more division. Let's do, just in case this is number 6, I'm going to have log base, or log of 12 divided by 11. So none of these ones have bases. If it had a base, so if it had like an 8 over here, you would write the 8 everywhere, okay? So this is going to look like log of 12, always your top, minus the log of the bottom. Okay, so now let's work with some powers. And then let's do a combination of a little bit of all of them. And even these ones are fairly simple ones. So if you get to harder ones on IXL or whatnot, just let me know and I'll help you out. Okay, so 7 is the log of the cubed root of x. Okay, this cubed root is going to become a power, which is kind of weird. So we need to rewrite this as a power first. Okay, because we don't want to write it as a radical form. So we're going to write it as log base x to the 1/3. And then from our power properties, we need to remember that just whatever number we have up top for our exponent gets to come out front. So this whole answer is just going to be 1/3 x log x, and no more 1/3 up there, okay? It's just up front. Okay, sometimes we're going to be given numbers and other pieces that we actually can simplify a little bit more. So when we get to those, we'll worry about those. Okay, let's do a combination of some of all of these guys together. John, Okay, so this is number 11 on this random worksheet I'm working on. You don't have to worry about what this worksheet is. I'm just using it for example problems because your book doesn't have a good amount of them. Okay, so this is log parentheses u dot v to the 6th power. So this dot is multiplication. Okay, so what this is going to look like, our first step, and there will be multiple steps, is to write your 6 out front. 6 times, let's put parentheses around that. Let's start off with that pattern or that habit. UV. Okay, so what this is going to happen with this piece right here is going to go to addition. So I have one more step that I have to take. This 6 will stay out front and still get parentheses around it. So then I'll have log U plus log V. Okay, so that is it. That's where you end. Okay, sometimes you just have to do more work than that. Okay, so that is an example. Let's do one more that's kind of looks similar, but not quite the same. So I have log of a b to the 5th power. Okay, and then definitely let me know if you can't see it or if I need to write bigger, okay? So what this is going to look like is the multiplication is the first thing I need to take care of. So I really have log a plus log b to the 5th power. Okay, so what that's going to look like is this 5 needs to come down and be in front of this. So I will have log a plus 5 log b. Okay, so you just need to pay attention with your exponents to which piece they go to. I can write a multiplication there if it's easier. Okay, and then the next thing we're going to work on is putting them back into the single log form. So now we'll be given like these pieces over here and be asked to put it in this tiny skinnier form. You need?
I didn't do anything.
Okay, so this first question that we have is log 6 minus log 5. Okay, so when it says to write as a single logarithm is something which all your directions will say. Single log. I'm just going to write log instead of logarithm. Okay, what that's going to look like, this minus, this subtraction, this difference is going to go to division. Okay, so that's going to look like log 6 divided by 5. Okay, again, if you have whatever base, you keep whatever base you have the whole time. I need to change my screen timeout on my phone. Okay, so if I have, I'm just kind of skipping random numbers just in case you find the same random worksheet. If I have log 6 plus log 7, okay, so all these have a base of 10 and I'm just not writing it. That's our invisible base. Okay, that is going to look like log 6 times 7. And every once in a while, you might see something else change this. So I don't know what your IXLs will look like. You might actually need to change this to 42. Okay. I would be okay with this with everything we went over. I just don't know about that IXL step, what it's going to ask you for, okay? 17 is going to be 3 log x. So what we're going to do with this thing out front, this 3 out front, we're going to move it to that power of x. So your answer really is just log x cubed. Okay, next one I'm looking at is 21 is log, I will go ahead and post this worksheet and it has the answers on the back side of it in case you wanted to look at them. I have log x plus 5 log y. Usually, the first thing we're going to take care of is any whole numbers in front of our logs. Okay? And even if they were not whole numbers, there's any numbers in front of there. They could be fractions as well. Okay, plus, we're going to change this 5 to y to the 5th power. Okay, now that we have an addition right here, we're going to change that into a single log that's going to look like this one log that you're only writing one. And you're going to have x times y to the 5th power. Okay, the order that you write these two things in are not important as long as it's the y that has the 5 on it. Okay, you might see something else. I'm just kind of taking up what room I have to write in. So this is number 18, and that wasn't the one I meant to write, actually. Let's do 20 instead. Okay, so log x divided by 2. Your first step in thinking this one through is to write the divided by 2 as a 1/2 log to the x. Okay, this 1/2 is going to go to my power of x. I'm going to have a log x to the 1/2. This, I would be mostly okay with this. If you wanted to take it one step further, we could remember that a half is the same as a square root. So you could also write it like log square root of x. So these are both equal right here. All 4 of these are equal, actually, but those are good. Okay, that would be a good step to take and recognize that it's there. We can do like lines of things as well, okay? Okay, so log u plus log v plus log w, okay? So be ready for that. You're gonna have multiple ones in a row. Okay, so that's what that looks like is since it's all multiplication, it is just u, or since it's all addition, it's just gonna all be multiplication. Okay, we do not need to create those dots. You can just write log UVW. Okay, so then we could have 22 is going to look like 6 log U minus 6 log V. There's a couple different ways you can think about these sixes. I'll just go with the first way that I see, but it doesn't necessarily have to be the only way to do it. Okay, so it's log U to the 6th power minus log V to the 6th power. So this is a minus, that's going to become division, and you're going to have log U to the 6th divided by V to the 6th. Okay, we could also write this one other way, and that could be log U divided by V all to the 6th power. Okay, I think this will be enough to get you started, and we'll just do IXLs for homework this week. I think I have 5 of them picked out for you. I will type them as well, but it is R9, 10, 11, 12, 13. I want you to get these properties down really good, and then we will start using them to solve.